Hey everybody. So welcome back. This video is all going to be about how to find the area of a sector. And for the whole video, we're going to use this equation here. Area equals 1/2 r squared theta. In the next slide, we'll talk about basically what all of these pieces are. But essentially all we're doing is we're trying to find the area of a slice of a circle, which is basically the missing area of Pac-Man. Think a pizza slice, things like that. We're going to calculate those areas. So here we go. So let's talk about the equation. So what does each piece of the equation mean? Because if we know that, then these things are easier to figure out, right? So A is area. So this is ultimately, most of the time, what we're after. We're after the area. R is the radius of whatever circular thing we're talking about. And theta is what we call the central angle. Central angle. I know that's spelled incorrectly. Central angle. And so what is the radius? The radius is the length from the center of whatever circular item, thing, whatever, sometimes it'll actually be circles, to any side outside, to any place along the edge, the perimeter. Right, so that's the radius. The central angle is the angle formed right here. So this would be the central angle. So if I wanted to measure this white sector here, basically what's the area missing out of Pac-Man? What would I need? Well, I would need the central angle and I would need this radius. So if you have a central angle and you have a radius, you can calculate the area of that particular sector. Also, we'll see in the next example, if I have area, right, and I have radius, I could calculate my central angle. Or if I had any of these two variables, so there's three unknowns here. There's the area, there's the radius, and there's the central angle. If I know any two of those, I can solve for my missing one, and that's going to come in handy as well. So you're just going to use the skills of, hey, how do I solve for missing variables in an equation? And if you can do that, you can find area of a sector. So let's move on. Let's look at some actual examples now. So keep in mind, area equals 1/2 r squared theta. So let's find some areas of some sectors. So our first one, what if we know, and again, area equals 1/2 r squared theta. So what if we know that theta is equal to pi over 5? Okay, theta is equal to pi over 5, so I'm going to sub that in for theta. And what if I knew my radius was 3 meters? So I'm going to sub that in for r. So that gets squared. Right, so this is just a simple substitution. And then I go and figure out along my way using orders of operations. So the 3 gets squared first, so that's 9. So now I have just a bunch of multiplication, which is fun because I basically just, oops, that's a pi. The 5 is on the bottom. Basically, you just get to run these things together. 1 times 9 times pi, 1 times 9 times pi, and on the bottom 2 times 5 is 10. So the area is going to be 9 pi over 10 meters squared. Area is always squared because it's two-dimensional. So I know that this would be 9 pi over 10 meters squared. Perfect. Let's move on. I can get all of this in one swoop. Oop, almost. Need to hit every little piece. There we go. Okay, now what if the sector formed, so again, pizza slice, or missing Pac-Man, formed by central angle of 30 degrees, has an area of pi over 3 centimeters squared. Find the radius of the circle. So this isn't asking us to find area, it's telling us the area, and it's telling us the central angle. So this is what I was talking about before. What we don't know is radius, but we know 2 out of the 3 things, right? Area equals 1/2 r squared theta. What are we given? We're given the area and we're given the theta. Solve for r, right? If you're given 2 out of the 3, you can solve for the third, and that's what we're going to do. So our area is pi over 3. 1/2. We don't know what r is, but we do know what theta is. Theta is going to be 30. Now we have a little bit of an issue here. Not so much of an issue, but I want to make this look a little better. I have something in terms of like a radian measure, and I have something kind of in terms of a degree measure here. I either want to convert it all over to radians or I want to convert it all over to degrees because I really only want to deal with one type of unit of measurement. So what I'm going to do is I'm going to convert pi over 3 to 60. So pi over 3 I'm going to convert to 60, right, radians to degrees. 1/2 r squared times 30. And now I'm going to go through and I'm going to divide out, right? Because all of this is multiplied. So the first thing I'm going to do is I'm going to hit this all with a divide everything by 30. You don't have to do it in the order that I'm doing it. So 2 equals 1/2 r squared. I'm going to get rid of that 1/2 now by multiplying everybody by 2. So 1/2 and 2. 2 times 2 is 4. So I'll have 4 equals, these guys blew each other out. 4 equals r squared. Square root both sides to get negative and positive too, but because radii are always positive, r is going to be equal to 2. So I figured out the radius. Now here, given the central angle and given the area, right? Again, you can solve for any piece in this equation. Let me hit this with the eraser again. It's like bonus points if I can get it all in my one erase. No. Ha. It's like really satisfying doing that. Okay, and lastly, well, how do we apply this to like a real world situation? So lawn sprinklers, right? If you guys have ever seen a lawn sprinkler or even like the lawn sprinkler dance where you're like doing this, it goes in a perfect sector, right? If it's not going all the way around. So we have a lawn sprinkler that's located at the edge of a lawn. So here's my lawn. Here's my lawn sprinkler. And the sprinkler is set to rotate through 110 degrees. So that's the edge. That's the edge. And this is 110 degrees, right? And it's going to... So it's something like that. So the lawn sprinkler, if you've ever seen a lawn sprinkler, this is basically how they work again, if they don't circle all the way around. So, and then what else do I know? I know my central angle and water out 40 feet. That means the radius. That means the water shooting out 40 feet. So I have a radius, I have a central angle. So now let me find the area of this lawn that's watered by the sprinkler. Basically, can you find the area of this sector? So A equals 1/2. What's my R in this case? My R is 40 squared. You can see these numbers are going to be big. And my theta is 110. So area is equal to 1/2. 40 squared is going to give us that 1600 times 110. So area is equal to 1/2 times 1600 is 800. I'm doing this step by step. 800 times 110. Let me just verify my numbers. Yep, 88,000. So area is equal to 88,000. So this is like the world's most powerful sprinkler. 88,000 feet squared because we are area and we're told our units were feet. So this is literally like the world's strongest sprinkler that I've ever seen. 88,000 feet is huge amount of land covered by this monstrosity of a sprinkler. All right, so there's our answers. And yes, please. And that's going to be it for us. So everything we've done. So we've discussed how to find the area of the sector using A equals 1/2 r squared theta. What's the r? It's the radius. What's the theta? It's the central angle. The A is the area of the sector. We figured out that, hey, if we only have 2 of those variables, we can solve for the third using what we know about how to solve equations. Also, we saw that these do have some real-world implications as far as sprinklers, or you can think pizza slice, Pac-Man. Anything that's going to take a slice out of a circle, we can now calculate that area. So as always, if you guys ever have any questions, please don't hesitate to ask, and I'll see you guys next time.